Hello everyone, welcome to the channel. Today we're going to discuss about inter-VLAN routing. And also I also have a packet tracer lab that we're going to do. So before we do the packet tracer lab, I just wanted to discuss about this VLAN routing, inter-VLAN routing, and what we need to understand this before we do the inter-VLAN routing packet tracer, so you have a better understanding of what's going on. So I thought, I just put this video together to give you kind of brief um, background on inter-VLAN routing. So when we do the packet tracer, you have a better understanding what we're doing there. So we know that VLANs are used to segment switched layer 2 networks for a variety of reasons, right? If you have multiple departments and you want to assign them different VLANs or different network, you would implement VLANs to achieve that goal. And then we know that VLAN cannot communicate with host, or one VLAN cannot communicate with host in another VLAN unless there is a router or layer 3 switch to provide routing services. And inter-VLAN routing is the process of forwarding network traffic from one VLAN to another VLAN. That's the feature of inter-VLAN routing. And so it has three options for routing. One is legacy inter-VLAN routing, and this is a legacy solution. So this is just for a small network. And it does not have a capability to scale up. If you were trying to expand from small to medium, the legacy will not be a good choice because you cannot upgrade um, or scale very well. There's second one, which is the router on a stick, and this is an acceptable solution for a small to medium sized network. So you have capabilities to move from a small, small to medium, so it will handle that load. And then there's another one, layer 3 switch using switched virtual interfaces, and this is the most scalable solution for a medium to large organization. So if you are moving from medium to large and you have a more networking, you need to do more routing, then you would implement layer 3 to achieve that goal. So um, i'm gonna I'm gonna give you, I have another slide where I'm gonna talk about um, what's the difference, the main difference between legacy inter-VLAN routing and router on a stick inter-VLAN routing, because we have a packet tracer and router on a stick inter-VLAN routing that we're gonna do right after this um, presentation. Okay, so legacy inter-VLAN routing uses physical interfaces. Okay, works, but it has a significant limitation. So everything has to be physically connected. Okay, it does not have um, the virtual or VLANs features that you can implement, and it is not reasonably scalable because routers have a limited number of physical interfaces, right? So it kind of puts restriction on that, um, expanding on on that numbers. So and then it also requires that the one physical router interface per VLAN quickly exhausts the physical interface capacity of a router. Um, so that's one downside about legacy inter-VLAN routing. But when we talk about the router on a stick, inter-VLAN routing method overcomes all of that limitations, right? Um, it only requires one physical Ethernet interface to route traffic between multiple VLANs on a network. Um, that's the awesome feature about router on a stick, that you only need to have one physical Ethernet um, connection to your interface to route multiple um, multiple VLANs on a network or between multiple VLANs on a network. Okay, so that's it for the kind of the brief explanation on inter-VLAN routing. So we're gonna go over to the lab now and work this lab. Okay, so we're actually gonna configure router on a stick inter-VLAN routing, and this is gonna be really interesting lab. And so objectives, part 1, add VLANs to a switch, configure sub interfaces, and test connectivity with inter-VLAN routing. Awesome. So a scenario, in this activities you will configure VLANs and inter-VLAN routing. You'll then enable trunk interfaces and verify connectivity between VLANs. Okay. And then instruction, part 1, add VLANs to a switch, create VLANs on a switch number 1, create VLAN 10, VLAN 30, and switch number 1. Okay, so we are gonna create VLAN 10 and 30 on switch 1. Okay, so we have a switch 1 here. Go over to the switch 1 and do enable config term, and then gonna create VLAN 10, and then we're gonna create VLAN 30. Okay, all right. So, and then step 2, assign VLANs to ports. So we're gonna assign ports to those VLANs. Okay, configure interface F6, fast Ethernet 6, and FO11 as access ports and assign VLANs. Okay, and then we're gonna assign the port connected to PC1 to 10. So okay, so and then assign the port connected to PC3 to VLAN 30. Okay, so as you can see here, so PC1 or VLAN 10, that's gonna go over to interface 11, and then the other one gonna go over to 6. Okay, so all right, so let's do interface F0/11, and then switch port mode access, switch port access VLAN 10. Okay, 11 gonna go over to 10. Yep, looks good. And then interface F0/6, and then switch port mode, and also mode access. Then we're gonna do switch port access VLAN, that's gonna be 30. Okay, all right, that's good. Now we're gonna do gonna move right here. All right, now issue the show VLAN brief command to verify VLAN configuration. All right, let's do that now. So VLAN brief. Okay, now as you can see that VLAN 10 active on port 11, and then 30 active on 6. Okay, awesome. All right, so then step 3 is test connectivity between PC1 and PC3. All right, let's ping. Yeah, all right, I can just drop, so copy this, click this, and then drop one here, and then drop the other one here. Okay, it failed, so it's not pinging. So and there's asking, were the pings successful? Why did you get this result? So we got failed, right? So it didn't ping. Why? So ping were not successful because they're on different VLANs, right? PC1 is on VLAN 10, PC3 is in VLAN 30. So we haven't configured anything about trunking or any of those stuff, right? To have them communicate. We just assigned it port. We created VLAN 10 and 30 and then assigned port. So that's all we did. And they're on different VLANs. Okay, that's the main answer they're asking about. So all right. Okay, so part 3, what we're gonna do is configure sub interfaces. So we're gonna configure sub interfaces. All right, that's why. Okay, enable config. Okay. All right, so we're going to int get 0/0-1. Oops. And then we're going to do encapsulation T1Q0. And then IP address 2.168. 117.110.1 and 255.255.255.0. Okay, awesome. Now we're gonna repeat and then it says repeat for the 30 sub interface. Okay, all right, let's repeat 0/0.30 and then encapsulation on Q. It's gonna be 30. And this one 17.117.30.1 255.255.25. Okay. All right. Now, verify configuration. Use the IP interface configuration command to verify sub interface configuration. Both sub interfaces are down. Sub interfaces are sub interfaces are virtually interfaces that are associated with the physical interface. Therefore, in order to enable sub interfaces, you must enable physical interface that they are associated with. Enable, we're gonna enable this gig 0/0 interface and verify that the interface are now active. Okay, so first we're gonna, let's go ahead and enable that. Yeah, let's go ahead, let's do this. So you're gonna exit out of this, config term interface, and then no shutdown. Okay, all right. Okay, so we did that. We enabled the interface. Now test connectivity with Inter-VLAN routing. Ping PC1 and PC3 should it still fail. Okay. Alright, let's do that. I'm gonna actually just gonna click here and drop this, drop that. Okay, so it still failed, right? Okay, so the ping should still fail. Explain. So the switch is not yet configured with a trunk port, right? That is connected to the router. So we still need to configure the trunk port that's connected to the router. That's how we're gonna be able to ping PCA and PC1, PC3. Okay. All right. Now, if I go, now it says enable trunking on S1. Issue the show VLAN command. All right. So this is gonna be switch. All right. Let's do. So VLAN. Okay. And then say what VLAN is gig 0/1 assigned to. Gig 01 slash is assigned to VLAN 1 default. Because the router was configured with multiple subnet interfaces assigned to different VLANs, the switch port connecting to the router must be configured as a trunk. Enable trunk on interface gig 1. Okay, so we're gonna enable that. So how can you determine that the interface is a trunk port? Using the VLAN command. So so the interfaces is no longer listed in the command output. Okay, issue the show interface trunk command to verify that the interface is configured as a trunk. So what we're gonna do first, we're gonna enable trunking. Okay, so config term, so it's gonna be gig 0/1 switch port mode trunk. Awesome. Now if I do so VLAN, oops, what am I doing here? So VLAN. Okay, now as you can see, it's not there. Okay, the interface is no longer listed here. That's what I said in the command output. So how can you determine that interface is a trunk port? So because it's now listed here, so it must be a trunk port. All right, so now let's go ahead and issue so interface trunk. Now there you go. Native 1 trunking status. Now there you go. Port gig 0/1 is our trunk port. Okay. Now if our configurations are correct, we should be able to ping now PC1 and PC3. I'm gonna drop this here, the other one here. Oops, still failed. Okay. I'm gonna, let's do this. Let's ping it. We are at 100% completion, so we did everything correct. I don't know why it's not pinging. This 0. There you go, it's pinging. I don't know why it failed there. So let me drop this guy again just to see. Successful. There you go. Yeah, maybe it just needed that. So anyway, all right, so we are at 100% complete.